So you touched briefly on the focus of your company. You said architecture and design, or art and design.
Sure. So I started in 3D printing in plastics as well, because that's what I knew. So we actually developed a machine that printed with recycled household plastics. But there were already a lot of printers out there in plastics, and I think plastics right now has got a bad rep. It's not a very popular material, especially in terms of sustainability. And concrete just had more potential, and it's a very good material for architecture, and I enjoy architecture a lot. So it was a good combination for me from the technique. So our company focuses on doing the more high detail things. So a lot of aesthetics and high detail. So within concrete 3D printing, you actually have two main strategies. One is what we call mono-material printing, and two is what's often called two-component material printing or accelerated printing. And the first one,
I think it's a K1 and a K2 mix, right?
Sure. Yeah. If you like, it's one component, two component, right? K for component, not so much in English, but in other languages.
Yeah.
So you have the one component, which is just your basic powder material. You run through a pump, add water, and you print robot or gantry. The two component actually adds an accelerant at the nozzle to harden the material within 30 seconds. So we are one of 3 companies in the world that have developed and sell this technology. And the main advantage of this technology is that it hardens the concrete so fast that you're able to produce extreme angles. So normal mono material is 5-10 degrees, but we can do 60 degrees. And our patterning is much more detailed, because if you do that with a mono material, it falls down. So you need to accelerate really, really fast to make very beautiful designs and
so
very extreme
make the
angles.
K2 mix or the nozzle head?
The mix and the nozzle.
Oh, so the first time I heard about this K1 and K2 mix was when I visited 20 Additive Manufacturing in Canada.
Sure. Yeah.
Yeah, they're great guys. I absolutely love them.
Yeah.
Such fun.
Yeah, Ian's great. They're friends.
So he was telling me about the nozzle head, and he showed me the nozzle head that they had. Did they buy that from you?
No, they bought that from a competitor in Austria called Baumit.
Okay.
Yeah, so they use the machine from Austria. So there's 3 in the world robotics that do this. One is Baumit in Austria, one is X3 in France, and we are the 3rd.
Okay.
So on the robotics side, there's actually one also gantry producer, which is Sika, but that's a whole nother category. So we are basically the only 3 that do this, and so within concrete printing in general, we're actually the niche, right? So everybody's printing houses right now, and it's so capital intensive that if I wanted to print a house here, the material for one house alone on the current prices on concrete, you're looking at 80,000-90,000 euros of concrete alone.
Yeah.
That doesn't make any sense if you want to buy a house for 400,000 euros to have 90,000 euros of concrete, right?
Just for your walls. Yeah.
Right. But also I can't afford to try out 90,000 euros worth of house just to see if it works, right? So it's a very capital intensive thing. And we're much more focused on the design side. So the robotic side fits with that. The material side fits with that. So we develop our own material mix and our own nozzle. And they're now really focusing on being front runners in that niche.
So is the mix still a motor mix, not a concrete mix?
Right.
Okay.
Right. So, I mean, you will know that concrete printing is generally mortar printing.
Yeah.
So smaller than 3 millimeter grain, which again is very good for the design side, and because it makes for smooth printing, and not so great for the housing side because it's expensive.
Yes.
Yeah.
So what about like dealing with compressive strength when you don't have any like aggregates in it?
Yeah.
Do you all use fiber reinforced?
You don't need to. The compressive strength is still extremely high. So we're still looking at 50, 60 MPa because we use so much cement. And now that's an issue for sustainability. So there are many efforts right now to reduce the amount of cement in the concrete printing mix. The reason why we don't do that yet is because there are 4 elements to concrete printing: material, software, robotics, and pumping, in my opinion. We are very good at the software and the robotics side. We have partnered with a very good pump company, and the material side is quite difficult and requires a lot of effort. So we are waiting on other firms to produce this material, and then we will buy it and use it for our technique.
Okay.
So it's not our main focus, but there are many companies working on that right now.